Welcome to STA309 Week 4 our tutorial session. Today we'll be going over the homework number 4. In the chapter of the book, it covers the probability, and we really do not have a lot to cover in R. But I'll just go over some functions that you can use to solve the homework set number 4. First of all, we always like to upload the Excel file to our R Studio. I'm using I named our homework, the set, as a homework for data for data.csv. Take the matrix. Well, before we talk about the R, let's open up the homework for file first. So if you open up the file, here we have variables here and the other variables here. So these data is in matrix form. Okay. This column looks like the sum of all the white families, and this looks like the sum means the family. There are 2 adult generations living in a family, and here there are 2 skip generations, means grandparents living with grandchildren, and 3 or more generations, just basically meaning that there are multi-generations living together. Okay, this is if we run, let's just skip the first row. Deal with this. If you run this first row here, I'm going to run this. Just taking our CSV file as data2. Let's open up data2. So this is how the data2 looks like. It's taking a matrix. Some row is just taking whole data as a matrix. So here it's saying that one of the variable for the white family is 786. This is not something we don't want to see. We just want to see a matrix with these variables and these 3 columns. To do that, we can run this the second row here. What it does is basically until here is the same. But here we are specifying the row from 1 to 4 and the column from 1 to 3. So if you run this, I'm taking this as data 3, run it. Okay, so this is how we want to see our matrix. So for our matrix has 4 rows, white, Hispanic, black, Asian, and 3 columns, 2 adult generations, 2 skip generations, and 3 or more generations. Okay, so our data or matrix looks fine now. This function is we are indexing some vector. We're indexing a value from our matrix. But we put the data 3, put a big bracket, and specify the variable white, and the column x2 skip generations. Before running it, we can assume that it will show the value of this, and let's run. Okay, so it's showing the value we expected. The row 5 here, the sum function is summing the data this vector value. Okay. Before we do that, let's run this first. Data3, big bracket, Asian. Okay. We know that in the bracket we put the row first and the column last. Then here for the column we are not specifying anything. Okay. Let's run it. Okay. The values here. Okay. Then if you sum the vector here, we sum this vector here, which is 65 plus 1 plus 44. If we do the sum data 3, it's just giving us the grand total, the whole. Okay? So we can see that there's for white family 786, Hispanic family 292, black, Asian, etc. If we open up our Excel file with the margin value equals 1, we know that it's giving us the row sum. If you run the margin table with the margin equals 2, these values matches with these values. Margin equals 2, this command gives us the margin. Then just running the margin.table just give us the grand sum of the values in the matrix. Okay. The row number 13 and 14 is something not really necessary for the homework, but then it's good to know if you want to learn R continuously. The command is cbind. Stands for, I think it's column binding. So we have the data 3, which was the 4 by 3 matrix, but we don't have any like sum here and the sum here. If you want to see the sum column here added, then we can do the sum bind, which was the row sum. Go back. It was the result was this. So basically what we are doing is we are binding the columns of matrix data 3 and then the marginal, the row sum. And I'm storing that as data 4. Let's run it. Could you repeat that?
So the margin equals to at the right side.
Yeah. Okay. So we can open. So it just added the sum column. They automatically assign the variable as v4. So if we want to change that to some kind of name, put the column names, and we specify what column. The fourth column of the data 4, which was this v4, we are changing the name of v4 to sum. So run this and open up data 4 one more time. The column name changed. That the other one is a prop table. Just let's run the prop table first. I'm using the data 3, not the data 4. Okay. So this is our result. Okay. So basically what it does is it's giving us the proportion of each item of matrix. Okay. So the sum of these numbers should equal to 1. Okay. If we specify the margin equals 1, it's give us the row proportions. Okay. Let's run it. the row sum should be equal to 1. Okay. So for example, we can say that for out of all Y family, the two adult generations, the proportion of two adult generations is about 64%. Okay. Same thing goes to the other Hispanic families and Black families, Asian families. So the let's say row proportion. Okay. The prop table with margin 2 is the column proportion. If you see this column here, you can kind of eyeball it and then see that the sum of this column is 1. Generation families out of, I mean, again, the proportion of the Y families out of two adult generation is 61%. Okay? So we can mix something up. We can mix a prop table and the margin table and then run the command. Okay? Here we know the margin table with the margin 1 give us the marginal, the row or the sum of the rows, right? So if you run the prop table of the row sum, all families, the Y families, the proportion of Y family is 54%, Hispanic family is 20%, and so on. And the sum of these numbers should equal to 1. So we are mixing up the margin table and prop table. I mean, it doesn't have to be margin equals 1. We can do prop table. Sure. The problem, the question was whether finding the probability and everything. Yeah, we can just use the R as a calculator to solve the problem. I mean, these are just the tricks that if the matrix is really big or we have a lot of data, then just picking one or indexing one item and then like finding the sum of that item takes up time. So like knowing these commands reduces a lot of unnecessary time, I think. Okay. So for example, these are questions I modified a little bit. I found from the homework set. For example, what is the probability that the multi-generational family is Asian? So just we are looking for the probability. Okay. Already did that question. We figured out the Asian family is about 7% or 7.6%. The second question is what is the probability that the multi-generational family selected at random is white and skip generational family. So here is looking for the joint probability, right? So this is just asking the probability that the family is white and we can compute. We can use RS calculator by using the indexing, or we can just go to here. The probability that the generation family selected is white and skip, white and skip. If there's 53 families are there out of 1438. Mm-hmm. Mm-hmm. Out of 1438. Yes. Yes, we'll go over that too. Yeah. So, for example, yes, what is the probability that the randomly selected Asian multi-generation family is two adult generation family? Yeah. It's a two adult family, given that Asian family. The next problem is what is the probability that a randomly selected multi-generation family is black? Family is black, given that family is skipped generation family. Okay. Right? Mm-hmm. So, okay, so probably a black family given that it's a skip generation family. So we look at the sum of the column first. So there are 99 two skip generation families. And out of there are 39 black families. Yeah, so we can just go use. Thank you for coming. This is the end of our tutorial session.